Okay, so now we're on module 3, which is going to be the first of the math modules. So the directions for the math are shown up here as they would be on the actual exam. You should read them in preparation for taking the SAT exam. So when you get to the real test, you definitely want to spend time on that. Notice there is a calculator up here. So there's a built-in graphing calculator, which has Desmos. Whatever calculator practices, be sure to make sure you have those dialed in before test day. And like it says, some students use a physical calculator. So I will sometimes be using this physical calculator as part of the problems. So I will have that out at times. I also have Desmos here opened up. Remember, Desmos is this graphing software. There's also a reference guide. So this reference guide cites certain formulas. Most of the formulas have to do with geometry, but there's also some formulas about angles and things like that. So just note that you have that reference guide. I would recommend really learn and know that reference guide. Don't memorize the formulas in the reference guide, but definitely know which formulas you have access to on test day that you don't have to have memorized. So that's the end of the instructions, and we're going to get started. Remember, what I'm going to do is I'm going to hide the timer. The directions are shown up here. Keep something in mind about the directions. When it comes to math, if your answer is 3.5, 3.5, 3.50, and 7 halves, 7/2 are all correct. But do not do mixed numbers. Do not do 31/2 or 3 space 1/2. Don't do that. When the answer is 2/3, make sure that you write it as 2/3. Do not write it as 0.66, okay? And again, any repeating decimal, I highly recommend just go ahead and write that as the fraction form. I'm going to definitely recommend for the math section, we go through just right in order, because the earliest questions tend to be the easiest, then medium, then difficult questions. So early questions, you should be able to knock them out in 30 seconds. And questions that are more medium difficulty, closer to a minute. Questions that are more difficult, 1.5 or 2 minutes. By the way, I am also going to use this for my blank scratch paper. So imagine I have some physical paper in front of me that I do some calculations on. So I will be using that at times. Okay, so let's get it started here. It says, which of the following frequency tables accurately represents the given data for question number 1? So we have 1, 3, 3, 4, 4, 4, 5, 5. Okay, so frequency table is going to be the number of instances that a certain data value has occurred. So there's 3 4s. So we look for the number 4. So here's the number 4. And does it occur 3 times or 12 times? Well, just 3 times. Now the others should be correct. 1 occurs once, 3 occurs twice, and then 5 occurs 2 times. Okay, so we have choice C for the correct answer. We'll move on. It says, which expression is equivalent to x squared minus 11x plus 28? Okay, so notice that these are all in factored form. Scan the answers before what you're going to do. So given that these are all in factored form, we need 2 factors of positive 28 that add up to negative 11. So that would be negative 7 and negative 4. So x minus 4 and x minus 7 would be indeed the factors. So this is going to be exactly the factored form of this quadratic function. We can move on. Keith is paid $22 per hour on weekdays and $35 per hour on weekends. He works for D weekday hours and W weekend hours, and he earns a total of $685. Which equation represents his situation? It's $22 per hour for D hours. So dollars per hour times D hours is going to give the number of dollars. So it says which equation represents his situation, earning $685. That should be 22 times D, and then he also works weekends. So also means and, which is add. So plus 35 times W, which is the weekend hours. So I'm thinking that choice C is exactly the right answer. 22D plus 35W equals 685. Don't overthink it in terms of the early math questions. It should be something somewhat straightforward. We can move on. Question 4. In triangle JKL, the measure of angle J is 67 degrees. The measure of angle K is 24 degrees. What is the measure of the angle L? So if you go to your reference guide, which I clicked on up here, you'll see the sum of the measures of the degrees of the angles in a triangle is 180 degrees. Hopefully you're aware of that. That's a well-known property from geometry. So getting out my calculator, I'm going to suggest we do 180. Then let's go minus 67, because that's angle J, minus 24, that's angle K, and then we should get the remaining angle, which is angle L, 89 degrees. So choice B for the correct answer. And then we can move on. Question 5. The graph represents the speed y of a gravity-powered roller coaster over time x throughout its entire 75-second round trip. What is the most likely interpretation of point P on the graph? Okay, so let's think about what's happening here. Y is the speed, x is the time. Notice what's happening is, here we have the greatest speed, and then it's significantly decreasing to here. So if it's significantly decreasing, we can think of one of two things. That we're braking, so we're engaging the braking system, slowing the roller coaster down, or we're going up a hill, which would sort of slow the roller coaster down. So is the roller coaster accelerating or decelerating? It goes from higher speed to lower speed, so it's decelerating. So we can safely eliminate choices A and B. So is it decelerating, traveling uphill or downhill? The way this graph looks, it almost looks like it's going downhill, but that just means the speed is decreasing. I actually think it's going uphill. Remember, if you go uphill against gravity, that should slow your speed down. So choice D, I believe, for the correct answer. We can move on. We eliminated choices A and B. Let's look at question number 6. Now, this is our first math question that is free response. So we have a fill-in answer here. So we have to actually type in the numerical answer. So we don't have multiple choice. The table summarizes the distribution of the colors and logos on 100 shirts. So we've got Shark, Lion, Lightning, and then we've got totals here. And then we've got blue, green, and red, and totals. If one of these shirts is selected at random, what is the probability of selecting a shirt with a lion on it? Express your answer as a decimal or fraction. 40 lion shirts out of all of them, and there's 100 total shirts. So if I just randomly select a shirt out of all 100, 40 out of 100, which is 4/10, which is 2/5. Now that would be 0.4, because 40 over 100, we'll use the calculator just to prove it to you. So 40 over 100 is 0.4. You could also use the math mode to put it as a fraction, so 2/5 I think would also be a fine answer. Okay, I think we can move on. Question 7. Of the 40,000 fish in the city aquarium, 2,000 were selected at random and tested for elevated blood nitrate levels. Based on the test results, researchers estimate 25% of the fish in the entire aquarium have elevated blood nitrate levels with a margin of error of 6%. Based on these findings, which of the following is a plausible value for the total number of fish in the city aquarium with elevated blood nitrate levels? 25% of the sample, so 25% of the sample would be 500 fish in the sample we found to be infected. But 25% of the total number of fish is what we have to assume. So 25% is 0.25 as a decimal multiplied by 40,000 fish in the overall aquarium, and so that would be 10,000 fish. So we expect 10,000 fish. Now I don't see that in terms of the choices, but it also says what is a plausible value. Okay, plausible, that makes this math question a little more difficult. Plausible means possible. They sometimes on the SAT use the word could be. So what that means is 10,000 is the most likely number of fish, but it also has to be within the margin of error. If you're within the margin of error, then it's a plausible value. Now, what is 6% of 40,000? So let's go ahead and notice I put my calculator back up to the top line because I wanted to repeat the calculation, but just change this to 6%. So 6% is 2,400 fish. Totals that are within the margin of error would be 10,000 minus 2,400 and 10,000, or sorry, plus plus 2,400. Okay, so that would be 12,400. So plausible values could include 7,600 up to 12,400. So what is the only choice that is in that range? That's going to be D. It's not A, because A would be 25% of the sample. So D is the correct choice. Hope that makes sense. We'll move on. Here we have another fill-in question for number 8. What is the positive solution to the given equation? X equals 90 over x plus 9. So for number 8, we have x equals 90 over x plus 9. Now how do we solve this? So I'm going to recommend we should multiply both sides by x plus 9. Why? Because that eliminates the denominator and gets the unknown out of the denominator. So by doing that, it cancels on the right-hand side. On the left-hand side, we've got x times x plus 9 equals 90. Now you may say, why isn't it x plus 9 times x? You can switch the order of multiplication. Usually better to have a small term out front. Then we can distribute. Now why distributing? Because if you distribute, you're going to get an x squared, which is a quadratic. So we're going to need to get this in standard form to factor or to solve it. So we're going to have x squared plus 9x equals 90. I suggest we subtract 90 from both sides because that's going to get the quadratic equation in standard form. X squared plus 9x minus 90 equals 0. And let's see if we could factor this. So we need two factors of negative 90 that add up to positive 9. We could consider 9 and 10, but 9, if 10 was positive and 9 was negative, then it'd only be positive 1. So is there another set of factors? So I believe 90 might be divisible by 15. So 15 and 6. So let's see, if I had the 15 is positive and the 6 is negative, so positive 15 minus 6, that is 9. So that's going to be perfect. So this should factor to two binomials, both multiplied by each other. This is how we factor a trinomial. Hopefully you learned this in Algebra 1 or Algebra 2. And negative 90, that add up to positive 9 would be positive 15, negative 6. Careful, negative 6, negative 6. Notice we get x equals negative 15 and x equals 6. Now notice we're looking for, let's go back to the original question. We're looking for the positive value. What is the positive solution to this equation? So we're not going to use x equals negative 15. We're just going to use only x equals 6. So we're just going to plug in 6 for the correct answer, and then we'll move on. Number 9, a water tank is leaking water at a constant rate of 5 gallons per hour. The tank is also being filled by a hose at a constant rate of 25 gallons per hour. Before the tank is filled, what type of function best models the relationship between volume of water in the tank and time? Is it decreasing or increasing? And is it linear or exponential? It's leaking water, but it's also being filled. But the rate of filling is greater than the rate of leaking. So I think that the water is going up, so we can eliminate the decreasing. Now, if you're not sure, go ahead and guess between one of those two. But let's think about what's going on. 5 gallons per hour and 25 gallons per hour are constant rates. A constant rate means we're always every hour going to gain 20 gallons per hour, every single hour. So the function should look like y equals 20x plus something, where 20 is the slope, 20 is the rate, 20 is the rate of increase. So I think it's increasing linearly because it's a constant rate of increase. An ever increasing rate of increase would be exponential growth. So hopefully that makes sense. We move on. How about number 10? It says the given function is graphed in the xy plane where y equals f of x. What is the x-intercept of the graph? Okay, so x-intercept is going to be when we cross the x-axis. That's when y is equal to 0. So I'll show how to do this two ways. The first way is the algebra paper and pencil way. Okay, so over on the doodle paper, I rewrote the function, and I'm going to let y equal to 0, which is like letting the function output value equal 0. So we've got 0 equals 12 times 1/4 raised to the x minus 3. So we want to solve for x. That means we've got to add this term over, because if I knew what x was, I'd be putting it in there and then raising and then multiplying and then subtracting. So the exact inverse order of operations is to add 3 to both sides. So by adding 3 to both sides, we get 3 equals 12 times 1/4 raised to the x. If I divide by 12, notice that continues the inverse order of operations in solving. 3 over 12 is 1/4. So I have 1/4 equals 1/4 raised to the x. Well, now this is the one-to-one property, because this is the same thing as 1/4 raised to the first power, because 3 over 12 simplified to 1 over 4. So x has to equal 1. So the point would be 1, 0. So let's look back at the original question, and 1, 0 is indeed the x-intercept of this graph. So I hope that makes sense for the x-intercept. Could we use Desmos for this? And the answer is most definitely yes. So if I type f of x, I'm going to go equals 12 times, parenthesis, then I'm going to go 1 over 4, using the slash, raised to the x, and then minus 3. Now, I need to move myself out of the way for a second, but hopefully you can still hear my voice. And if you click, look at that. That's the x-intercept, 1, 0. Okay, so we have the correct answer. We can move on. Okay, let's go into question 11. It says, the circle shown with center K has a circumference of 48 pi. Triangle LMN is inscribed inside circle K. LM is equal to MN. If angle LMN is 30 degrees, what is the length of arc LM? I'm going to doodle this on the paper. One of the unfortunate things about not being on the paper SAT is that you can't just draw straight on a geometry diagram. You sort of have to recopy it, if you will, on your paper now. So I'm drawing a circle, and I know that, LM and MN are the same. So that means this is an isosceles triangle. So that means this distance here is the same as this distance here. L, M, N. Let's connect this. We also know that LMN, the angle is 30 degrees. LMN. So this is a 30-degree angle. Now, hopefully you recall from isosceles triangles that the base angles of an isosceles triangle are congruent. So that means this angle here is the same as this angle here. Now, because we know the sum of the interior angles of any triangle is 180 degrees, we can figure out what each of these angles is. We can use the calculator for that. Okay, so using the calculator, we have 180, then we'll go minus 30, and then we get 150, but that's split over 2 angles. So let's divide by 2, and we get 75. So that means each of these angles here is 75 degrees. We can start looking back further. We say the circumference is 48 pi, but let's think about how this works. If a triangle is inscribed in a circle, hopefully you're aware there's a theorem with circles that says an inscribed angle subtends half of the arc that it's associated with. In other words, here, 30 degrees, this is going to be a 60-degree arc. And then in a very similar way, this 75-degree angle will subtend an arc from here to here that you have to double 75. So that's 150 degrees for the arc. And then last but not least, I know you're on the edge of your seat, but this 75-degree will also subtend a 150-degree arc. But if you add 150 degrees, 150 degrees, and 60 degrees, that's 360 degrees for the total arc of a circle. It turns out we are looking for arc LM. So LM is we have marked here in blue between L and M. That's 150. But notice that's the same thing as 150 is to the total circle 360. In other words, we're comparing it to the total arc of the whole circle. We're comparing the part to the whole as a ratio. Well, what should that equal to? What other arc? Well, it should be the length of arc LM, which we've got here in blue, because that's the part, compared to the circumference, because the circumference is the distance all the way around the circle. Now, what is the circumference of this circle? It was given in the problem, right? 48 pi. So this is 48 pi, and then LM is x. It's the unknown value we don't have. Now let's see if we can simplify this right here, 15 over 360. In fact, I want to get that as simple of a fraction as I can get it. So 150 divided by 360. So let's throw that to a fraction. In other words, it's 5/12. Now that kind of makes sense because if I divided them both by 10, it'd be 15 over 36. Then divide by 3, that's going to be 5/12. So 5/12 is equal to x over 48 pi. Now, if you're clever, hopefully you realize the scaling factor here is 4 pi. If I multiply 12 by 4 pi, I get 48 pi. So if I multiply this by 4 pi, I get the answer. So x should be 5 times 4 pi, which is exactly 20 pi. And that, ladies and gentlemen, should be the correct answer. So 20 pi is choice C. So that's the arc length. You may ask, could I have solved this by cross multiplying? Yes, you could have. Now, if you'd have taken 150 times 48, you'd have gotten a very big number. Okay, so 150 times 48 is 7,200. We still have the pi. And then equals to 360x. So if you divide by 360, so take the previous answer, 7,200, divide by 360, you will get 20, and then we still have the pi, and that's x. So remember, x is the arc length of this arc shown here in blue. So this was the arc that we cared the most about. So that was a more difficult math problem. We definitely took some more steps. Hope that makes sense. We'll move on. Hey, you're enjoying this content, please go to highpeakeducation.com. Let us help you with your educational studies, with your SAT prep, your standardized test prep, math, science, meteorology, physics, statistics, computer science, all kinds of things we can help you with at this channel with our free resources or our paid resources. Work with us. Work with some of our high-level, top-notch, first-class educators, highpeakeducation.com. Thanks for listening to this little commercial. Let's get back to today's video. Okay, how about question 12? It says the area of a square A is defined in square units, and it's defined by this expression, 9x squared plus 6x plus 1 square units. What is the side length of the square in linear units when x is equal to 4? Hopefully you recognize 9x squared plus 6x plus 1 is a trinomial that is a perfect square. In fact, it will factor. So 9x squared, the square root of that is 3x. The square root of 1 is 1, and 3x times 1 and 1 times 3x will give 6x. So what I'm trying to say is that 9x squared plus 6x plus 1 will indeed factor to 3x plus 1 times 3x plus 1, which is the same thing as 3x plus 1 squared. Now squared, remember, the reason we call it squared, power 2, is because that gives an area of a square. Imagine this is our square, where 3x plus 1 is one of the sides, and 3x plus 1 is the other side. Remember, all the sides are equal in a square, right? Well, that means a side is exactly equal to 3x plus 1. But wait a minute, we know that x is equal to 4, so we can plug that in. So that's 3 times 4 plus 1. Order of operations, 3 times 4 is 12, plus 1, that gives 13. So this is a 13 by 13 square. In other words, all four sides are 13 units around. So that is choice B. Hope that makes sense. Okay, question 13. It says, a botanist is studying the fungus population in a controlled environment. The table shows the exponential relationship between the time t in weeks since the study began and the total amount S of fungal spores that exist in the designated study environment. If the scientists do not add any fungus spores after the experiment begins, which of the following equations best represents the relationship between t and S? If it's an exponential equation, what that means is we need to consider the original amount. So notice 3 of the 4 choices have a 3, 2, 7, 1. So that means that's sort of like the original amount. Now I'm going to suggest that, 3,271 for the initial, is going to be when t is equal to 0. Now, if I set t equal to 0 in any of these here, notice choice A is immediately out. Because in choice A, if you set t equal to 0, anything raised to the 0 is 1. So you would get 2, 2, 2, 9, which is incorrect for the initial amount. In choice B, we have a negative exponent, but the base is a decimal. So that's actually going to be exponential growth. Whereas if you look at choice C is 1 minus 0.12. But 1 minus 0.12 is 0.88. 0.88 for a base with a positive exponent is like continually multiplying by a decimal, which means it's going to be exponential decay. We see that this is exponential decay for the fungus population, whereas B is exponential growth. Now take a look at D. D should be also exponential growth. So believe it or not, I think we actually know it is choice C. Now let's see if we can further substantiate that this is the case. So what we can do over on our scratch paper is for number 13, we know S of 0 is 30271. So let's write that down. S at time 0 is 3271. Let's see if we can understand what's happening to this population. If we used choice C, would a base of 0.88 be appropriate? So we propose S of t is equal to 3271 times 0.88 raised to the t. So let's let t equal 1. So after one time unit in weeks. So if we put in t equals 1, notice we have 3271 times 0.88. So that gives us 2878.48. 2878.48, is that the same thing as what we see here? I believe so. Let's instead look at 2 weeks. So 2 weeks, you multiply by 0.88 twice. In other words, 0.88 squared. Does that give us this number? Yes. And then how about this raised to the third power? Indeed, that's correct. Now, if you were on the actual exam, hopefully you'd be working through this a little more quickly than what I'm doing right now. I'm showing you other reasons and justification why this is the correct answer. Okay, so we can move on. Okay, so let's look at number 14. It says, how many points of intersection do the graphs of the equation y equals 1 minus x and y equals 1 plus 1 over x have in the xy plane? What we can do is we can set these two equations equal to each other. They're already set it equal to y, so we can do the algebra that way. Okay, so we've now set them equal to each other. 1 minus x and 1 plus 1 over x are now set equal to each other. So I'm going to recommend in this part of the equation, let's just multiply by x. We're trying to get x out of the denominator. With the unknown being trapped in the denominator, that's harder to solve. So we can distribute here, and then we're going to multiply by x both sides, so we can distribute here. So that's going to give us x minus x squared equals x plus 1. Now let's get this in standard form. So we've got negative x squared, starting with the quadratic term. Then we subtract this x over. But if we subtract x from both sides, they cancel. And then we'll go minus 1 equals 0. We can multiply this equation through by negative 1. So we would get x squared plus 1 equals 0. That's x squared equals negative 1. But if you take the square root of both sides, you would get an imaginary number. You would not get a real number. So that means there's not going to be any x values for which they do intersect. So I'm looking at 0 times that they intersect. Now, let's go ahead and see if we can confirm this with our friends over at Desmos. Okay, so we have 1 minus x for the first function. Then we have 1 plus 1 over x for the second function. Now, I don't know what you think. I'm going to move my viewing window out of the way, but it looks to me that there are no intersections. I can zoom out a ways, but it turns out it looks like there aren't going to be any intersections, right? So zooming out, no intersections. That's because this is a line with slope negative 1, y-intercept 1, and it doesn't hit the parts of this, what we might call hyperbola or rational function, okay? So Hope that makes sense. No points of intersection. Okay, so we'll move on from question 14. Number 15, we have another fill-in. Dirk buys a quantity of water bottles, W, and hot dogs, D, for his family at a baseball game. It costs him $24. The given equation represents this situation. How much more expensive in dollars is a bottle of water than a hot dog? If it's W water bottles and D hot dogs, notice 6 times W is the cost of the water bottles. 3 times D is the cost of the hot dogs. But that means a water bottle costs $6, a hot dog costs $3, and so the difference between them, how much more expensive is a bottle of water than a hot dog? That would be 6 minus 3, which is 3. Dollars difference. Hope that makes sense. Now we're going to go question 16. It says a store owner reduces the price of a particular vintage coat by 20% every day until it is sold. The original price of the coat was $140 and it's sold after T days. Which of the following represents the final price P paid for the coat if T is greater than 0? Well, think about this, right? We're reducing the price by 20% each day. That means the coat maintains 80% of the price each day. So that means we should multiply the coat's price, original price, 140, by 0.8. Why 0.8? So the complement of 20% is 80%. 80% of the coat's value is retained. 80% is 0.8 as a decimal. 0.8 as a decimal raised to a power T, that's going to give us choice A. So it's going to be choice A because we always going to multiply by 0.8. Now, we have to be very careful here though. And that's because if T was equal to 0, then the coat would be $140. Notice it says, which of the following equations represents the price P paid if T is greater than 0? So we're going to reduce the price of the coat 20% every day until it's sold. Okay? So B is definitely out because that's a linear equation. And then let's check out if C and D could possibly be correct. So it's not 0.2 or 1.2. Okay? Because again, here what we'd be doing is we'd be multiplying by more than the price of the coat in D. So that's definitely out. Now let's think about what's going on here for C. Could C possibly be the correct answer? Notice that 140 minus 140 times 0.2. So 0.2 is the amount of discount. So if T is greater than 0, suppose T equals 1, that means we're going to take the cost of the coat minus the original cost of the coat times 20%. So 20% of that gets subtracted from the cost of the coat. So which is it? Is it A or C? Is it going to be 20% of the previous day's price? Or is it going to be, we're going to reduce it by 20% each day? So it says, store owner reduces the price of a particular vintage coat by 20% every day until it is sold. So by 20% every day. So I'm leaning towards A. Now, to some extent, they should actually make this, should they say 20% off the original price? If it's 20% off the original price until it's sold, that'd be choice C. But I'm going to go with choice A. All right, so I wish they would write this question a little more carefully, but good enough, we'll move on. Okay, question 17. It says a cylinder has a volume of 90 pi cubic meters and a height of 10 meters. What is the diameter in meters of the cylinder? So let's go to our reference guide. So here's our cylinder. Notice that the cylinder has volume pi r squared h. So what I suggest is we sketch a cylinder like this and we write down what we have and we're going to look to figure out the diameter. So here's our cylinder. We're just going to sketch it. We don't exactly know if it's very narrow or very tall, who knows. But it's got a radius and this is its height. We know its volume is 90 pi cubic meters. Its height is 10 meters. So let's label that. This is 10 meters. And then 90 pi is equal to the volume, and that's equal to pi r squared h. This right here is capital V, the volume. Do you see that the pi's are going to go away both sides? If you divide by pi, they cancel. So then we can also plug in 10 for h. So that's going to be 10 times r squared is equal to 90. Let us divide by 10. So if we divide by 10, then r squared, the radius squared, is equal to 9. Take the square root. When you insert a square root into the problem, you should insert plus and minus with regular algebra, but given its geometry, we're going to assume the radius is positive. So we take the square root of both sides. Square root of 9 is 3, because 3 times 3 is 9. So r is equal to 3. And then last but not least, we're not looking for the radius, we're looking for the diameter. So the diameter is the distance all the way across, and the diameter should be twice the radius. So twice the radius, d is equal to 6 meters. So that should be our answer. Let's go back to the choices. Notice 6 meters for the correct answer. Not 3. Not 3. 3 is the radius. I guarantee so many students are going to choose 3 and they're going to get it incorrect. That's a ghost answer. That's a distractor answer. Watch out for the distractor answers on the SAT exam. They are meant to throw you off. So don't do that. Also, remember, it's not 9 because 9 is r squared. All right, let's move on. Okay, it says the given system of equations is plotted in the xy plane. What is the x coordinate of the point of intersection? Well, in order to get the x coordinate of the point of intersection, we could add these equations together to get something to cancel out via linear combination. So let's do that. So we have 4x minus 9y equals 7. Then we have 2x plus 3y equals 11. Okay, so the second equation, if we multiply by 3, we will have an exact equation that has the same coefficient on the y's, so we can just add and cancel the y's. So let us recopy the first equation, but then the second equation becomes 6x plus 9y equals 33. Notice we multiplied all the coefficients by 3. If we add this equation to the other equation, then the y's go away. So we just get 10x equals 7 plus 33 is 40. So after the y's canceling, then we just get x is equal to 4. Why 4? Well, if you divide by 10, because if x is multiplied by 10, the inverse is dividing by 10. So x is equal to 4. Okay, so we're just looking for the x coordinate. So the x coordinate being 4 should be the correct answer. Now, could you do this with Desmos? Yes, you could. Let's go ahead and do that. So the first one is 4x minus 9y equals 7. Then we have 2x plus 3y equals 11. Okay, so I need to move my camera out of the way so we can see the intersection. I'm going to do that. Where these two intersect should be the correct point of intersection. So we're just looking for the x coordinate. So the x coordinate should be x equal to 4. Okay, so Desmos confirmed we have the right answer, and we'll move on. Okay, number 19, in triangle LMN, the sine of L is equal to 91 over 109, and M is a right angle. What's the value of tangent N? So let's sketch our right triangle, M being the right angle. And again, it's LMN. So if we sketch this triangle, we're going to have something like this. So there we go. So this is a right angle. It's LMN. Now, for reasons I'm not going to explain, because 91 over 109 is close to 1, I know the sine of that value is large, so I know that the opposite side here is very large compared to this side. Now, it's the sine of the angle L. So we're looking at angle L, first of all, and the sine of the angle L is equal to 91 over 109. So sine is the opposite side over the hypotenuse of a right triangle. So that means this side is 91, this side is 109. Okay, so far so good. We're looking for the tangent of angle N. Now angle N is up here. So it's different than this angle here. The tangent of angle N is going to be side LM over side MN, which is 91. Now, we're looking for the value in terms of a fill-in here, so we need to simplify this fraction. Now, let's consider, do 109 and 91 have any common factors? So let's investigate that. It turns out that in your math menu, if you're using a TI-84 Plus type calculator, that under num, you have LCM and GCD. LCM is least common multiple, GCD is greatest common divisor. So the greatest common divisor of 109, I'm going to do a comma there, and 91 is what number? Well, it's 1. So it turns out that we can't use either of those. So what that means is I can't divide by any number here. So I just have to use the Pythagorean theorem. I just have to use a squared plus b squared equals c squared. Notice that is in your reference guide here. So a squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is the hypotenuse. So we could call this side a, and then this is b and this is c. Or sorry, a squared plus 91 squared is equal to 109 squared. So let's get 91 squared and 109 squared in the calculator. 91 squared should be that big number, and then 109 squared should be that big number. Okay, so we have a squared plus 8281, so 8,281 is equal to 11881. That's 11,881. Okay, so we're going to subtract this number because we need to isolate a squared. So we have a squared is equal to, let's subtract these two big numbers in the calculator, and then we have 3,600. Now that makes me kind of happy because 3,600 I think is a perfect square. If I do the square root of 3,600, that's going to give us 60 on the nose. So that means a squared 3,600, a is equal to 60. So then, with this tangent, we're going to go 60 over 91. Now let's see if 60 over 91 simplifies. 60 over 91, or doesn't simplify at all. So 60 is 6 times 10. There's a lot of factors, but 91 doesn't have that many factors. 91 is almost prime, I think. So anyway. Good deal. All right, so that's all we got to do. We just got to do 60 over 91. 60 over 91. So that was kind of a harder question. I definitely would not suggest putting the decimal in there. Did you see that the decimal was very long? Okay, so we have the right answer. Let's move on. The given equation defines the function f. For what value of x does f of x reach its maximum? Well, this is a quadratic, and it's a downward-facing quadratic. So it has to be at the vertex. So hopefully you recall, when doing a quadratic function, the vertex, when you have a quadratic function in standard form, the x value is given by negative b over 2a. So if a is negative 8, b is 16, we can say that the x of the vertex is equal to negative b over 2 times a, which is negative 16 over 2 times negative 8. Well, that's just negative 16 over negative 16, which is just going to be 1. So that's the x value of the vertex. But then we want to know for what value of x does it reach its maximum, so that's just going to be 1. Now, once again, can we use Desmos for this? The answer is yes, 100% we can. So we're going to go negative 8x squared plus 16x, and then plus 2. Sorry, plus 2. All right, so then we have to go up here and look for the maximum value. So if we click on it, there it is. Look at that. The x value is 1, and then the y value is actually 10. Now what we could have done here is we could have taken x equals 1 and plugged it back in here. I guarantee we would have gotten 10 for the function value. So if they, on a different exam, if they ask what's the actual maximum value, you would answer 10. But otherwise, Desmos confirms that we should exactly have x equals 1, y equals 10. And they're just asking for the x value. So we're just going to say x equals 1. Okay, so we have it correct. Let's move on. Okay, 2 questions left. In the xy plane, line V passes through the point 0, 1 and is parallel to the line represented by the equation y equals 3x minus 9. If line V also passes through the point 8, w, what's the value of w? Well, parallel lines have the same slope. So we realize that the slope must be 3. Because y equals 3x minus 9 is in slope-intercept form, where m is 3 and b is equal to negative 9. So the slope must be 3. And we're also going to pass through this point. When x is 0, y is 1 for our line v. So we're saying the value of b for our line v is equal to 1. So this is going to be a pretty straightforward calculation because m equals 3, parallel, b equals 1 because the point 0, 1 is on the line, And then we're looking for the y value when we pass through the point 8 comma something. So that's y equals 3x plus 1. Now notice that should be exactly parallel. This is line V. That should be exactly parallel to this line, 3x minus 9. But now let's plug in x equals 8. So if we plug in x equals 8, we get y equals 3 times 8 plus 1. And that is the value of w. One of the things the SAT is famous for in the math section is introducing additional letters, which is kind of unnecessary. So they wanted you to solve for w, but w is really just the y value when x equals 8. Okay, so 3 times 8 is 24, and then plus 1, so that's 25, equals w. Let's see if we can confirm this on Desmos. So the original line was 3x minus 9. It's plotted there in red. I'm going to be moving myself out of the way likely in a moment. The other line we came up with was 3x plus 1. When you're using Desmos, make sure you use the little clicker here to have it selected so it kind of goes through right there. Okay, so there's the y-intercept. Now we just need to look for the point where x is equal to 8. So we need to go way over here to 8 and then go up to the blue line. So we go up to the blue line when x equals 8. Aha, look at that. Do you see it? We clicked on it right there. When x is 8, y is 25. So Desmos exactly agrees with us. What's the value of w? 25. So we solve that in 2 different ways. Hope that makes sense. And here is our last question on this module 3, the first of the math modules. Another free response fill-in question. In the xy plane, a line with equation 2x plus 5y equals 15 intersects a parabola with equation y equals 2x squared plus 3 at exactly 2 points. For the 2 points of intersection, x comma y, what is the lesser of the 2 y values? So there's a couple ways we could do this. But I'm going to suggest let's do the algebra way and then the Desmos way. So for the algebra way, let's go ahead and take y equals 4x squared plus 3 and plug it into this linear equation. So we're going to put in 4x squared plus 3 right there. So 2x plus 5 times 4x squared plus 3, and then equals 15. Okay, so we have to distribute this 5. So we've got 2x plus 20x squared plus 15 equals 15. Okay, now very conveniently, we would try to get this in standard form, but if subtracting 15 from both sides, we're going to get a 0 there. So we just get 0, and then we've got 20x squared plus 2x. So now, this is a factorable polynomial from a greatest common factor. In fact, you can factor out 2x, and you're left with 10x plus 1 equals 0. So you get 2x values. X equals 0 or x equals, let's see, what would this be? X, so that's a little tougher because it's 10x plus 1 equals 0. That's 10x equals negative 1. That's x equals negative 1 over 10, negative 1/10, because we divide both sides by 10 here. Okay, hope you see how I did that. So those are the 2x values. So we got to plug those in to find the y values. Remember, y is equal to 4x squared plus 3. So if I plug in x equals 0, that's y equals 0, because you put in 0 there, that whole term is 0, plus 3. You just get y equals 3. So one of the coordinates is 0, 3. If I plug in x equals negative 1/10, this is going to be a little harder. So it's 4 times negative 1/10 squared plus 3. Okay, so we have to square this negative 1/10. Now squaring a negative is positive. We're going to get 1 over 100. So it's going to end up being 4 over 100 plus 3. And that's going to give us, let's see, we want to get 3 in terms of, I'd say 25ths. Why 25ths? Because 4 over 100 is the same thing as 1 over 25. 3 in terms of 25ths would be 75 25ths. So I multiplied 3 as if it was 3 over 1 by 25 over 25. If I add these, I'm going to get y equals 76 over 25. Now 76 over 25 is just a little bit larger than 3. So it says what is the lesser of the two y values? That should be 3. Now, let's use Desmos to see if we can confirm. Okay, so using Desmos to confirm, we're going to go 2x plus 5y equals 15. Okay, so that's definitely a linear function because it's powers of 1 on both x and y. Then we need the quadratic. We need the second equation. So we need y equals 4x squared plus 3. So make sure you're selecting it. That's a quadratic that opens upward. Now, if you look carefully, those 2 points are extremely close to each other. So we really need to zoom in. So I zoomed way in, then I have to move up here. So we want the lesser of the two y values. So the lesser of the two y values is indeed 3. The larger of the two y values would be 3.04. I think 76 over 25 is 3.04. So we did get the correct answer. So the lesser of the two y values is 3. We are now at the end of this module 3. Great job on finishing the math section. So what you should do is you should click end. We're going to end the module. Are you sure you wish to end? You will not be allowed to check, add, or change your answers on this module. Yes. Hopefully you noticed that I even paused the other math section. Because here's the deal. On the actual SAT exam, you should take a little extra time whenever you have some extra time. Like if you finish the math section like a few minutes early like I did, you should take a little break. Even if it's just a stretch, even if it's just to not think about something. I would suggest definitely take your eyes off the computer screen. Computer screens, if we look at them for too long, can really put us in a bad state of mind. That ends this video. That ends module 3. That ends the third part of this full-length digital SAT exam. So, thank you very much for watching this video. And remember, at High Peak Education, we can help you with studying for your SAT or other math, science, other kinds of things. Please feel free to contact us. I am here to help you. My name is Paul Culette. I'm the founder of High Peak Education. We exist to make education ideas stick and to help you as a full education solution. So thank you very much for watching this video. Please go to highpeakeducation.com and support us, reach out to us. Let us know if you have any questions, comments, concerns, and let us know what other videos you want us to do in the comments as well. So thank you for your attention, and we'll see you in the next video, hopefully the last module in this series from this digital practice SAT.